Imagine a world where tiny machines repair damaged tissues from within. This is the promise of nanobiology. Nanobiology, an exciting frontier in scientific research, is a multidisciplinary field that merges nanotechnology with biology. Let's break that down. Nanotechnology involves the manipulation of matter on an atomic, molecular, and supramolecular scale, while biology is the study of life and living organisms. So when we talk about nanobiology, we're talking about exploring and manipulating biological systems at the nanoscale, which is 1/1,000,000th of a meter. This microscopic scale opens up a whole new world of possibilities. It offers a unique opportunity to understand the fundamental processes of life, right down to the smallest particles. In doing so, nanobiology is changing our understanding of biology, from how we perceive cellular processes to how we envision the future of medicine. Speaking of the future, the potential impact of nanobiology on health, environment, and technology is monumental. In the realm of health, we're looking at more precise diagnostics, targeted drug delivery, and even potential cures for currently incurable diseases. When it comes to the environment, nanobiology could lead to cleaner energy sources, more efficient waste management, and innovative ways to combat climate change. As for technology, imagine devices that operate on a molecular level, opening up new avenues in computing, data storage, and material science. But let's not get ahead of ourselves. As much as we're excited about the potential of nanobiology, it's important to remember that it's a field still in its infancy. There's still so much to learn, so many questions to answer, and so many challenges to overcome. But that's what makes it so thrilling. Each discovery, each breakthrough, brings us one step closer to a world where nanobiology is an integral part of our lives. Nanobiology promises to revolutionize our lives, but how does it work? Well, that's a journey we're just beginning. So stick around as we explore the fascinating world of nanobiology. It's going to be an incredible ride. To understand nanobiology, we first need to grasp the nanoscale. What is this mysterious nanoscale we keep mentioning? Well, nano is a prefix from the Greek word nanos, meaning dwarf. In scientific terms, it represents 1/1000,000th of a meter. So if you can imagine a meter stick, a nanometer would be 1,000,000,000 times smaller than that. To put it into perspective, consider this. A single sheet of paper is about 100,000 nanometers thick. If we zoom in even further, a strand of human DNA measures just about 2.5 nanometers in diameter. It's mind-boggling to think about, isn't it? Now, why is it so important to understand this incredibly tiny scale? It's because at this level, the properties and behavior of materials can change significantly. This opens up a whole new world of possibilities in various fields, including biology. In the realm of nanobiology, we study biological processes that occur at the nanoscale. For instance, the movements of individual atoms within a protein molecule or the interaction of a drug with a cell membrane. These processes are crucial to life as we know it, and by examining them at the nanoscale, we can gain a deeper understanding of how they work. Moreover, understanding the nanoscale allows us to manipulate it. Scientists are now designing and creating materials at the nanoscale that can interact with biological systems in specific ways. These nanomaterials could be used to deliver drugs more effectively, or to create sensors that can detect diseases at their earliest stages. The nanoscale, despite its diminutive size, holds immense potential. It is the frontier of biology where we're just beginning to explore and understand the complex intricacies of life. Now that we have a grasp on the scale of nano, we can start to uncover how it applies to biology. One of the most exciting fields where nanobiology is making waves is medicine. This is a realm where the tiniest of particles are making the most significant impacts. Nanobiology, the intersection of nanotechnology and biology, is revolutionizing healthcare, from disease detection to drug delivery. Let's first consider targeted drug delivery. Traditional drug delivery methods often distribute medication throughout the entire body, which can lead to unwanted side effects. However, nanobiology offers a different approach. By using nanoparticles, we can now engineer drug delivery systems that directly target affected cells, leaving healthy cells untouched. For example, In cancer treatment, nanoparticles can be designed to selectively bind to cancer cells, delivering the drug directly to the tumor and sparing the patient from the harmful side effects of chemotherapy. Moreover, nanobiology also presents new opportunities for early disease detection. By using nanoscale biosensors, we can detect biomolecular interactions that indicate the onset of diseases, years before symptoms may appear. These biosensors are so sensitive that they can pinpoint the presence of disease markers at incredibly low concentrations, potentially leading to earlier diagnoses and more effective treatments. Another fascinating application lies in the field of tissue engineering. Nanoscale scaffolds designed using principles from supramolecular assemblies are being used to guide the growth of new tissues. These structures provide the architecture necessary for cells to grow and organize, offering immense potential for regenerative medicine, and it doesn't stop there. Nanobiology allows us to probe the interface of biological systems using advanced spectroscopic techniques, offering a deeper understanding of biological processes at the nanoscale. This understanding, in turn, fuels the development of more efficient and effective therapeutic strategies. In essence, nanobiology is transforming medicine by enabling us to interact with the human body at an unprecedented level of precision. From targeted drug delivery to early disease detection and tissue engineering, nanobiology is pushing the boundaries of what we thought possible. Nanobiology is not just transforming medicine, it is also reshaping other fields. As we continue to explore the nanoscale, we're discovering that the possibilities are truly endless. Nanobiology is paving the way for sustainable solutions to environmental challenges. In our world today, environmental challenges are increasing at an alarming rate. These range from water scarcity and pollution to climate change and the degradation of ecosystems. But fear not, nanobiology has come to the rescue, offering us new ways to address these critical issues. Take water purification, for instance. Traditional methods of water treatment are often costly, energy-intensive, and not always effective at removing all contaminants. Enter nanobiology. Scientists are now developing nanoscale materials that can absorb or break down pollutants, including heavy metals, organic compounds, and even microbes. These materials act like tiny sponges or catalysts, attracting and neutralizing harmful substances. The result? Cleaner, safer water that's available to more people, more of the time. But it's not just about water. Nanobiology also plays a significant role in pollution control. Consider the problem of air pollution. It's a major health risk, and traditional methods of reducing emissions often fall short. But with nanobiology, we can create more efficient fuel cells and batteries, reducing the need for fossil fuels and cutting down on harmful emissions. We can also engineer nanoscale catalysts that can convert harmful gases into less harmful substances before they're even released into the atmosphere. And let's not forget about soil pollution. Contaminated soil is a major concern, affecting food safety, water quality, and ecosystem health. But with nanobiology, we can develop nanoscale materials that can remove heavy metals and other toxins from the soil, making it safer for plants, animals, and humans. And the beauty of all this, nanobiology not only offers us new ways to address environmental challenges, but it also does so in a way that's sustainable. These nanoscale solutions often require less energy, less material, and create less waste than traditional methods. They're a win-win for our planet and our resources. Nanobiology's impact extends beyond our planet's health. It's also revolutionizing technology. From faster computers to more efficient solar panels, nanobiology is pushing the boundaries of technology. This exciting field is paving the way for innovations that were once considered the stuff of science fiction, transforming the way we think about technology and its potential. Let's consider nanoelectronics, for example. Nanobiology is laying the groundwork for the creation of electronic devices that are smaller, faster, and more energy efficient than anything we've seen before. Imagine a world where computers are the size of a single cell, yet more powerful than the largest supercomputers of today. This is the potential of nanoelectronics. This isn't limited to computing. Nanobiology is also revolutionizing the field of sensors with the development of nanosensors. These tiny devices can detect and measure physical phenomena at the nanoscale, providing unprecedented levels of precision and sensitivity. They could be used to monitor environmental conditions, detect diseases at their earliest stages, or even measure the activity of individual molecules within a cell. In addition, nanobiology is playing a crucial role in the development of renewable energy technologies. Nanoscale structures have unique properties that make them ideal for capturing and converting solar energy, leading to the creation of more efficient solar panels. Similarly, nanobiology is helping to improve the performance of batteries, making them more durable, faster to charge, and capable of storing more energy. Moreover, nanobiology is contributing to the field of data storage. By manipulating biological molecules at the nanoscale, scientists are exploring new ways to store and retrieve data. This could lead to storage devices that are smaller and more efficient than current technology, with the ability to hold vast amounts of information. Finally, let's not forget about the impact of nanobiology on communication technologies. Nanoscale devices could enable faster and more reliable data transmission, paving the way for next-generation networks that can handle the increasing demands of our interconnected world. As we can see, nanobiology holds the potential to transform many aspects of our lives. The possibilities are truly endless, and we've only just begun to scratch the surface. As we continue to explore this exciting field, who knows what incredible innovations lie ahead? The possibilities of nanobiology are vast, and we've only just scratched the surface. As we look forward, the potential future applications and research areas in nanobiology seem limitless. This field, which sits at the intersection of nanotechnology and biology, holds the promise of transforming everything from medicine to environmental science and even technology. In medicine, imagine nanoscale robots navigating our bloodstream, identifying and eliminating diseases with surgical precision. This could revolutionize treatments for cancer, Alzheimer's, and other debilitating diseases. Similarly, in environmental science, nanobiological applications could help us develop more efficient ways to harness renewable energy or clean up pollutants. In the realm of technology, we could see the rise of nanoscale devices capable of performing complex tasks, from molecular computing to advanced sensing. These could lead to more efficient and powerful computers or sensors that can detect diseases at their earliest stages. But these possibilities are not without their challenges. One of the biggest hurdles in nanobiology is the complexity of working at the nanoscale. Manipulating and controlling biological processes at this level require a deep understanding of both biology and nanotechnology, and there's still much we don't know. There are also important ethical considerations. As with any new technology, we need to consider the potential societal implications and ensure that nanobiology is used responsibly. This includes considerations around privacy, especially as we develop more advanced nanoscale devices that can interact with our bodies and environments in unprecedented ways. Despite these challenges, the future of nanobiology is incredibly exciting. The field is ripe for exploration, and the potential for breakthroughs is immense. We're on the cusp of unlocking new ways to understand and interact with the world at the nanoscale. The future of nanobiology is bright, filled with infinite possibilities and challenges that will continue to push the boundaries of our knowledge. So why does nanobiology matter? This fascinating field, which combines nanotechnology and biology, has tremendous potential to revolutionize our lives. It offers new insights into the mysteries of life at the nanoscale, paving the way for groundbreaking discoveries in medicine, the environment, and technology. In medicine, nanobiology could give us more precise and effective treatments, from targeted drug delivery to better diagnostics. In terms of the environment, it could lead to sustainable solutions for pollution and energy issues. And in technology, it's opening up new frontiers in data storage, computing, and materials science. We've barely scratched the surface of what's possible with nanobiology. The future holds even more exciting prospects as we continue to push the boundaries of our understanding and capabilities. Nanobiology may sound like science fiction, But it's a reality that is reshaping our world in unimaginable ways. Stay curious, keep exploring, and you'll be amazed at what you discover.